Good morning, students. How are you? I think you all are fine. So now we will start with our topic, and today's topic is recursion. So we have already I already gave you some idea about recursion. Now again telling that recursion is what? Recursion is is when a function calls itself. Suppose there is a pow function and the pow function is calling itself. So this type of thing is recursion. Now it can also happen that the pow function is calling sum function and the sum function in again calls pow function. Okay, so this type of thing is also recursion. That means something function calling same thing actually. Okay, now in Java, as in other programming language, it supports recursion. So it is a form of repetition, but remember that it is not an iteration. Now you will often heard the term that is recursive definition. I think in maths you have done this thing. Now recursive definition is what? If we represent something in terms of itself, so this type of thing is known as recursive definition. Say here, for example, xn equals to x into x to the power n minus 1 for n greater than 1, and if n is equal to 1, the value is x, and if n is equal to 0, the value is 1. So the first one means this thing is known as a recursive definition. Okay, now in iteration what happens? It is non-recursive. So here we can represent xn equals to like this. Suppose primarily we know the value of x, that is 5, and we are multiplying 5x like this. Okay. Now while we are while you go for writing recursive functions, you should keep in mind that there are two cases, at least two cases. Okay, more cases can be there. So the two cases, first one is the recursive case and second one is the base case. Now recursion, as I told, that calling a function itself. So it is something like pow is calling pow function, pow is again calling pow function, pow is again calling pow function. So there must be somewhere where it should stop. Okay, now this stop condition is known as the base case. Okay, now base case is a small problem that we know how to solve and is the case that caused the recursion to end. So here in this example, we know that when the value of n is equal to 1, that time the value of xn will be x, and when the value of n will be 0, that time the value of xn will be 1. So this is the base case, and recursive case is the first one, means where x is represented in terms of this. Okay, now here is a simple example with the function power function x to the power n. That means we want to calculate x to the power n. Now here we have declared a function power xn. Now representing the power function in terms of itself. How? X into power of x comma n minus 1. And what is the base case? When n is equal to 1, this is equal to x, and when n is equal to 0, this is equal to 1. Okay, now this is the example. See, we will calculate a to the power b. Now here we are using buffer reader class. Okay, so that's why we are importing java.io.star. Okay. After that, we are creating an object OB of that power rec class. That is see here, it is the power rec class. We are creating an object. Why we are creating object? Because later on we will access the method with this object. After that, we declare some variables and give value within those variables A and B. See, giving value here A and giving value here B. Okay, now calling the pow function with parameter A and B and storing the result in arrays. See, the pow function only. See, now A will come in M and B will come in N. Okay, fine. Now here I am giving the terminating condition, that is if n equal to 1, return M. Otherwise you return M into pow M comma n minus 1. So n will decrease automatically, means always n will decrease by 1, and when n is equal to 1, this function will return m to the calling function. Fine. Now here I am just printing the res, nothing else. So if the output is A is 4 and B is 3, so it will come like this: 4 to the power 3, that is 64. Remember that in recursion, if there is no base case, then the recursion will be infinite and your machine will hang, or the recursion or the function calls itself indefinitely. Okay. Now here is a iterative version of this power function. Okay. Next, see computing factorial. Now I think last day I already told you about factorial. Factorial is what? It is also a term from math. I think you have done this thing, but if you don't have the idea, then I am telling you that factorial of any number is that number multiplied by the previous number up to 1. That is factorial of n factorial equals to n into n minus 1 into n minus 2 up to 1. Okay. 6 factorial equals to 6 into 5 into 4 into 3 into 2 into 1, like this. And factorial of 1 is 1. So the recursive definition will be like this: if n is less than 2, factorial of n is 1, otherwise factorial of n is n into n minus 1. Now we will write the recursive function as follows. See, in factorial int n, okay, then if n less than equals to 2, return 1, otherwise you have to do this thing. Now see this example, just a minute. Here you can see that I have taken the factorial of 5. You just read the thing, you will be able to understand. Okay, so thank you that much for today.